Okay guys, I'm going to do the drilling, and probably one of the things you might think about or you might not think about is how to set up your drill press if you have one, which I obviously do. And one of the things that will help you get your marks, your drills started properly, is a small center drill, and these are really stout. So you just put it in your drill press, and these aren't real expensive, but sometimes they are. Now you notice that turn this off. Notice that my vise moves around, but it is bolted in place, so it can't cock like so. And that's for when I actually clamp things in it. But in this case, I'm gonna have a really good hang on to my knife. So when I drill through, I'm not gonna worry about it catching and pulling it out of my hand, especially with this small drill. And about the biggest I ever go is 1/2 inch when I'm doing it this way, just for safety purposes. But for now, I can see my little pin pricks, and the center drill will actually find the center of the automatic center punch. So it's actually better to do it this way than to try to clamp it in a drill vise. So I'll probably speed this up in the video, but for now, after you use the center drill on all of your marks, then you can come back and pre-drill a hole, let's say 1/8 inch or 1/4 inch or something, and then drill it to size. The reason is the web on the tip of a drill bit is basically displacing the metal before the cutting edge gets to it. So if you try to use a great big drill bit, let's say 1/2 inch or 3/4 inch or something, without a pilot hole, it just takes so much pressure on the bit. You wind up breaking bits or not even being able to drill the hole at all. So it's always good to use a center drill, and then it's good to pilot drill and then go to your final drilling size. I need to demagnetize my bit here. So in fact, I'm gonna demagnetize my bit. I'll take you along for the ride because this is something that I made here at home. You can see this is just the center coil of an AC motor, and I've wired in a switch, which is right here, and then the switch is plugged in to my outlet. So when you'll be able to hear it probably. Nope, you can't hear it. But that's okay, because this drill bit is going to go right down into the center and then back out. You don't leave it on for long. Whoops. There we go. I didn't have my outlet turned on. Let's see if you can hear it now. Nope. But when you stick it down into the center, you'll feel it try to magnetize, will try to pull it to the side, and you really want to try to keep it in the center in order to demagnetize. There, I can feel it now. And then pull that out. Do it again. Oh, that's why, because it pulled too much juice on the switch. So turn that off, turn this back on. You can't leave this on very long, it gets too hot. Okay, there we go. Now we can put this back into my drill bit. my chuck, I mean. And hopefully it's demagnetized. It does it better with larger items. I don't know why, but it should do the trick. We will see here momentarily, won't we? Notice I'm not putting a lot of pressure. I'm not trying to jam this center drill through. Yeah, see, it's still, oh, it cleaned up much easier that time. So I think we did remove at least some of the magnetism. Anyway, these center drill bits, these centering bits, if you try to force them too hard, you'll break them. They're very brittle. They're very tough in terms of being able to drill the steel, but they're brittle because of that. So don't put a lot of pressure on these. Yeah, that took the magnetism off of it. Looks good. You might notice that the drill motor is, the motor for the drill press is going quite slow. That's a benefit of having a nice machine, is that you can really get the speeds and feeds that you want. Whenever you're drilling tough steels, it's the diameter of the bit that you're supposed to use in conjunction with the type of material. And so I learned from my grandfather, whenever you're doing tough steels, like 154 cm is no joke. This stuff is tough. The slowest you can go, that's just fine. You know, don't try to rush it. If you're in a hurry, you're likely to break a bit. And these are double enders, but you can break both ends pretty dang quickly if you're not careful. You'll probably notice that I'm not using cutting oil. I'm not going very fast. If I was really trying to push the speed and the feed of this thing, I would use cutting oil for sure. But I don't seem to have that problem or any problem with it at these speeds, so I don't bother. If your drill press is one speed only, or it's a pretty fast, low speed, you're better off to use cutting oil. So this is a 1/4 inch bit, and in this case, you can see that my center drill has gone all the way through, so I now have an 1/8 inch hole all the way around, so I can go up to 1/4 inch. But if I didn't have a through hole here, you'd probably want to go through with 1/8 inch and then go to your 1/4 inch. Like I said, the web on these bigger bits. Now you can hear that noise. Now I have a larger diameter bit going, right? That's because it's 1/4 inch here. So if you add a little oil, notice the difference. Go sharpen my drill bit, and I think you'll be able to hear the difference here in just a second. Much better. when it breaks through, you always want to grab a little tighter onto your knife because it's, now this is my pinhole or my rivet hole. I don't want to drill that. So, yeah. Now I'm going to show you what I was talking about. Let me get my fancy little pointer here. Hopefully you can see the space between, let's see, get the light better. The space between these two holes is more than 1/8 of an inch, and the space between these two holes is more than 1/8 of an inch. This one here that's a little too close together, but this doesn't have any structural use other than just, you know, taking some weight out, so I'm not as worried here, but I definitely want to keep my 1/8 inch web here and here because that's where my strength comes through for the rivet. Well, this is Jeff Conti, your YouTube knife mentor. Go out and have fun making a knife.